Today, I'm going to walk you through physical cluster replication and why you might want to consider it instead of traditional backup and restore. So what is physical cluster replication? It's an asynchronous, byte level and consistent way to keep two clusters in CockroachDB up to date. You'll have a primary cluster, which will asynchronously replicate its data at a byte level consistently to a standby. And the reasons you might want to use it are, let's say you have two data centers, but don't have access to cloud or a third data center, so you can't unlock CockroachDB's multi-region functionality. This would work well for you. Although in an ideal world, you would have access to a third data center, because then you can survive different failure models without having to do any kind of disaster recovery. And it also provides lower RPO, that's recovery point objective, and RTO, recovery time objective, than a traditional backup and restore would. In a traditional backup and restore model, you're backing up everything, and then you're having to restore into a clean environment, and that takes a while. That can take hours or even days, depending on how large your dataset is. With physical cluster replication, the RTO and RPOs are lower because that data has already been replicating to the standby cluster. Before we continue, I'll caveat that it's not feature complete just yet. I'm recording this in November 2023, and by early 2024, it will be more feature ready. At the moment, it's in public preview for version 23.2. So without further ado, let's crack on. I'm going to create two clusters. One is going to be my primary, and I'm only creating single nodes, but in the real world, this will be multi-node clusters. So what we have here on the left is the replication source. This is essentially the primary cluster. And I also have a replication target. This is the secondary or the standby. It's worth noting that while I'm using config profiles at the moment, you can achieve the same thing with cluster settings for both the source and the target. We'll make that distinction clear in the documentation. I'm starting them both in insecure. This is not recommended if you're streaming insecure replication data to your secondary, your standby. You're open to snoopers, man in the middle, and things like that. So I'll kick both of those off. In order to use physical cluster replication, you'll need an enterprise license. So I'm going to apply a license to both of these clusters. So now I'll run an application, and this application will connect to both clusters. Note that the URLs you see here, the 9001 corresponds to the primary cluster and 9002 corresponds to the secondary. You don't have to do it like this. You'd probably want to do it by way of load balancer. This is working for me locally, so this is how I'm going to do it. I'll connect to the database. I'll ping it just to make sure I've got a connection. I'll create a database if it doesn't already exist. I'll wait for Control-C, so I'll be able to handle the closing of the application, and then I'll start the work. So that creates the table. I'll create a table if it doesn't exist called measurement. It has a UUID primary key, a decimal value, and a timestamp. I listen for done, which is like a kind of poison pill. If I receive that, the application quits. After every second, we'll have a tick event, and I'll insert a row into the database to prove that I can connect to it, and I'll fetch out the cluster ID so I can show you what cluster we're currently connected to. If I get an error, I'll add it to the error count and display the number of errors that we've seen. Otherwise, I'll reset the error count and display the ID that we just inserted and the cluster ID that we inserted it into. That is simply a transaction. I insert the measurement and I fetch the cluster ID. Note that I just take the first 8 bytes or so of the cluster ID just to not overwhelm the console. I'll start the application. And what we're seeing is successful inserts, the IDs that we've inserted, and the cluster that we spoke to. So 599 corresponds to the primary cluster 599. Note that the standby is 8BA. So what we're actually doing at the moment is this. We're in phase 0, prior to replication. The application is happily writing to the primary cluster with no replication happening on the standby. Although it is up and ready, it's not receiving anything at the moment. Next, we'll start replicating from the primary to the standby. The standby still won't be active. It won't be necessarily in a consistent state to the primary because we haven't asked it to cut over yet. So at the point at which we ask it to cut over, it will be in a consistent state to the primary at that point in time. Next, I'm going to cause the primary to fail. I'll simply stop the process. And we'll see that the application starts to fail because it hasn't got a database to talk to anymore, and it can't talk to the secondary because cutover hasn't happened. Next, I'll start the cutover process. So we trigger a point in time to say everything up to this point in time should be consistent. And by that point, the standby cluster is in a pretty good state and almost ready to cut over. Once it's ready, I'll cut over. So the application will then start talking to the standby cluster. And I can do that because I've got both the primary and standby cluster in the URL. You might need to cut over with a load balancer in addition to the database cutover. I'm going to backfill the primary database from the secondary. And finally, I'll cut back to the primary. The application will then continue to talk to the primary, and I'll describe why you might want to cut back to the primary and why you might not want to run against the standby in a minute. So everything's chugging along, the application's happily talking to the primary. I'm now going to hop onto the standby database. So I've opened up a terminal to it. And if I show you the virtual clusters, you'll see that we have system and template. If I were to run this against the primary, we'd have system, template, and application. And we haven't got the application virtual cluster here in the secondary because it's a replication target. It's a standby cluster. So that's what I'll create now. I'm going to create a virtual cluster called application. It could be called anything, but I'm just going to call it application so it's consistent with the primary. It doesn't have to be. And I'm going to create it from the replication of application, the application virtual cluster on the primary. And that's where it is. That's the URL of the primary cluster. And again, I've disabled all security. So now if we run the same query again, we'll see that we're initializing for replication here. Now I'll just show just this one. So you can see we've already switched over. Our data state is now in replication mode. Just a couple of seconds ago, it was in initializing replication, and now we're actually physically replicating data from the primary. If our primary cluster were to go away, let's just say for a couple of seconds, you can see that the errors are starting to accumulate over here in the application. Now, with any luck, the primary would come back online and the outage would have only been a temporary blip for the application. But let's say it was not. Let's kill the primary again, and we can see that the application's now unhappy again. But this time, let's say we're now in a disaster recovery scenario. I want to fail over into the standby. So let's begin cutover. What I'm now going to ask the secondary to do is to complete replication up to a point in time. And I'm going to ask it to cut over to the latest available point in time that I have for the data. That's my cutover time, and that's guaranteed to be consistent with the primary cluster at that point in time. So if I show the virtual cluster now, you'll see it's happened actually really quickly. And depending on your primary cluster size, that may take a while. But because my cluster size is very small, it's already ready to cut over. If I start my virtual application cluster on the standby now, I'm signaling to the application that the standby can now be used for reads and writes. Let's start that and pay attention over here. Now we've gone from 599 as an ID to 8BA, the ID of our standby cluster. Essentially, the disaster has now been mitigated. But now you might be thinking, well, now we're writing to the standby, the primary is getting out of date. And that's fine, we can backfill the data, and I'll explain how to do that in a minute. Let's see what kind of state our data is in. Let's fast forward an hour and assume that the primary cluster is now available again, but the application isn't writing to it. It's still writing to the standby. I'm going to use a tool called MOLT Verify, which is a tool from Cockroach Labs, to figure out what we're missing from the standby cluster. So if I run that, we can see that we've got 93 extraneous rows, and that's going to keep on growing as we write data to the standby. But we've also got 20 missing rows, and that reflects what happened when I killed the primary cluster and any data that it hadn't had time to replicate to the standby at that point. Now, rather than backfill the standby, I'm going to fail back to the primary now. I'm just going to show you what's missing in the primary, and those extraneous rows that we saw in the secondary, they're going to be coming through as missing rows when I run this. So I'm seeing 140 missing rows, and that's going to keep on climbing as users of the system continue to write against the standby. And they'll always match. If I've got 10 extraneous rows in the standby, I'll have 10 missing rows in the primary, and vice versa. Not everyone wishes to cut back to the primary. It might be that the standby now becomes your primary database infrastructure, but it might not. Your standby infrastructure might be under-provisioned when compared to your primary infrastructure. After all, infrastructure is expensive. You might have only provisioned a slightly smaller subset of the primary infrastructure for disaster recovery purposes. And it also might not be as close to your users as your primary infrastructure was, so user latencies may have gone up. Now, we could fail back to the primary in exactly the same way that we failed over to the secondary. We could replicate everything that we've got in the standby to the primary, but that might not be exactly what you want to do. So let me whiteboard a little bit so you get a feel for what I'm talking about. Let's say we've got our primary here and our standby here. Let's say crudely that we've got rows A, B, and C in the primary. And to show that there is some missing data in both of the clusters, let's say we've got rows C, D, and E in the secondary. And that's going to keep on going as we're writing data to the secondary. This data here is any data that we missed when the primary became unavailable and wasn't able to replicate data to the secondary. In order to do a physical cluster replication, it has to go into an empty virtual cluster, which would necessitate the deletion of this data in the primary. So we would have lost rows A and B because they don't exist in the secondary. We would physically replicate C, D, and E into the primary cluster and then carry on using the primary again. But we're not going to do that because we can't afford to lose rows A and B. So getting back to our previous state, what I'll do is I'll copy any data that doesn't currently exist on the primary back into the primary database from the standby, and then we'll be up to date and everything will be consistent again. Let's do that now. Now here's a big disclaimer. The tool I'm going to be using for this, I wrote myself and I've only ever tested locally on my machine. I would strongly recommend against using it for production uses, so I'm not going to share the URL to the tool. Another concern you might have with cutting back to the primary, knowing now that you need to delete the original virtual cluster, is the database might be terabytes in size. So if you're deleting terabytes of data and then having to backfill terabytes more, that's going to take a really long time. So for that reason, we're working on a feature called fast failback. I don't know if that's going to be the production name of it, but that's what we're calling it at the moment. And that will allow you to very quickly cut back to the primary from the standby. These last steps are just for illustrative purposes. I'm going to kill the secondary cluster, which will start the application talking to the original primary. So we can now see that it's gone from 8BA to 599 again. I'll restart the standby and I'm going to run a tool to backfill the primary cluster with data that it's missing from the standby. With that run, if I do another MOLT verify against the primary database, we'll now see that there are 115 extraneous rows. That's data that we've now written to the primary that doesn't exist in the standby, but we don't have any missing rows. So the extraneous values are going to continue to go up, just as we saw the other way around when the standby was being written to as the kind of new pseudo primary cluster. And we're in a good place. We've cut back over to the primary. At this point, you can now resume replication to the standby cluster. You'd need to start from an empty virtual cluster, so that would need to be trashed on the standby, but replication can resume. So that was physical cluster replication. I hope it was useful for you. If you were running CockroachDB in a multi-region environment and one of those regions were to become unavailable, like I demoed just now, CockroachDB would self-heal. It's built to survive regional outages, so you're in a disaster prevention world. But physical cluster replication is great if you're running in a disaster recovery scenario. You only have access to 2 data centers, but still want to achieve lower RTO and RPO times compared to a backup and restore scenario.